So in this video we are going to talk about the chapter first, matter in our surroundings, and in this video I will tell you how to prepare the notes, and in this video I will tell you how to prepare the easy notes for the chapter for the better preparation for your exams. Like the topics in the chapter which we are going to cover, very first we will begin from the introduction of the matter, then the physical nature of matter, diffusion, characteristics of particle of matter. There are basically four characteristics that the matter is made up of: very tiny particles. Particles of matter have space between them, particles of matter attract each other, and the particles of matter are continuously moving. Further, these states of matter is divided into three states, that is the solid state, liquid, and the gaseous state. Then we will read about change of state of matter, then the effect of temperature, and in the effect of temperature we will read about latent heat of fusion, latent heat of vaporization. As I heat, the word latent means hidden. Latent heat of fusion, fusion means melting. The amount of heat energy required to convert 1 kilogram of solid at atmospheric pressure at its melting point into liquid state, and the amount of heat energy required to change the 1 kilogram of liquid at atmospheric pressure at its boiling point into gaseous state is called the latent heat of vaporization. Then after that we will read about the effect of change of pressure, because gases are liquefied and filled in cylinder by the effect of applying pressure and decreasing temperature. Then after that we will read about evaporation. And what is evaporation? Process of conversion of liquid state into vapor on heating is called evaporation. And after that the factors affecting the rate of evaporation. So these are the topics which are mentioned here, which we are going to cover in this video, and I will tell you how to prepare the notes for this. Very first we will begin from the introduction. Since early times human beings have been trying to understand their nature. Early Indian philosophers classified matter into 5 basic elements, so-called Panch Tattva, that is air, earth, fire, sky and water. According to them, living as well as non-living things are made up of these elements. And nowadays, scientists evolved to types of classification of matter on the basis of physical properties and chemical nature. So very first we will talk about the physical nature of matter, that is the characteristics of the particle nature of matter. Matter is made up of particles, very tiny particles, so-called atom. All matter constitute means combine. All matter constitute of very small particles. These small particles are called atoms, and atoms combine to form molecule. These particles of matter are too small so they cannot be seen by our naked eyes or simple microscope. For seeing these particles we need a compound microscope. Particles of matter attract each other, and particles of matter are continuously moving as they possess kinetic energy, that is 1 upon 2 mv square. Means if there is rise in the temperature, there will be rise in the kinetic energy, that is the velocity of the particle. The speed of the movement of the particle will increase. With the increase of temperature, kinetic energy of particles also increase. So particle moves faster, and like this the state of matter gets changed. Diffusion. What is diffusion? The intermixing of particles on their own is called diffusion. Like in water, when we put few drops of ink, it gets mixed up automatically without stirring it. So that is called diffusion. The mixing of the smell of perfume in the air, in the environment, in the room when we spray it. So that is so called diffusion. And this is so termed as the Brownian motion. The zigzag or the random path traveled by the particles of matter is called Brownian motion. Random means in any direction. They will move in any direction randomly. They are not going to move in a particular direction. Means randomly they can move towards any side, up, down, right, left, any direction. Okay, so that is so called Brownian movement, and this can be seen in the air when we spread the smell of a perfume or any agarbatti. So it gets mixes in the air and can be smelled to a far distance. Correct? And the smell of the hot sizzling food so reaches to your nose. But if the food is not warm, then what will happen? The motion, the velocity of the particles will be slow. They will be not moving faster. Means the kinetic energy will be decreased at the low temperature. But when the temperature is high, it is increased. The motion, the kinetic energy possessed by the particle also increases. So diffusion can be defined as intermixing of particles of two different types of matter on their own is called diffusion. The rate of diffusion increases on increasing the temperature of the diffusing substance by heating, means by providing heat. It is natural process. It takes place in solid, liquid and gas. And like this, the states of matter can also be changed on applying pressure and temperature. Now we will read about the characteristics of the particle of matter. Particles of matter have space between them. Gases can be compressed a lot because of the space between the particles is very much. And we can say the force of attraction, the intermolecular force of attraction between the particles, is negligible. So for example, we can take when sugar is dissolved in water, the particles of sugar disappear in water. This happens because the particles of sugar get adjusted in the spaces between the particles of matter. Additionally, you will notice that there is no rise of water level takes place when 1 or 2 teaspoons of sugar is added in a glass of water. This is because sugar particles get adjusted in the space between the particles of water and no rise in the water level comes in result. Second characteristic of the particle of the matter is that particles of matter attract each other because of force of attraction, and this force of attraction is called intermolecular force of attraction, which is exerted between the particles of a matter. Either it is a living being, non-living being, or any other physical component. Force of attraction between the particles of matter keeps the particles bonded together, and it is different in solid, liquid and gas. Actually, the solid have the maximum, liquid weak, and the gaseous negligible. The force of attraction between the particles of solid is greatest, between the particles of liquid is moderate, and between the particles of gas is lowest. Because of the lowest force of attraction between the particles of gas, we can move our hand through air easily. To move our hand in liquid such as water, we have to apply some force, but from a solid such as wood, we cannot move our hand. This is because the force of attraction between the particles of a gas is almost negligible. In liquid, the force of attraction is moderate, but it is greatest in solid. The force of attraction between the particles of solid, liquid and gas can be arranged in decreasing order as follows: solid, liquid and gas. Next we are going to talk about the states of matter. The very first state is solid state. The space between the particles is very less. The force of attraction between the particles is strong. Thus particles in a solid are closely or tightly packed. Solids maintain their shape even when they are subjected to external force, that is, they are rigid. Solids cannot be compressed. The kinetic energy of the particles is very less. That is, the motion in the particles, the velocity is very slow. And so, solids have an orderly arrangement of the particles. Therefore, solids have a fixed, or we can say a definite shape and volume. Second state is the liquid state. The space between the particles is slightly more as compared to solids, but still very less as compared to gases. The particles of a liquid can slip and slide over each other. They do not have a particular shape. They take the shape of a container. The force of attraction between the particles is strong, enough to hold the particles together, but not strong enough to hold the particles in a fixed position. That's why they do not have a definite shape, but a definite volume. Liquids do not have a fixed shape, but have a fixed volume. Liquids take up the shape of the container in which they are poured or kept. The kinetic energy of the particles is more than that of solids, but lesser than that of gases. Thus, liquids have a disorderly arrangement of particles compared to solids because of the weak or moderate intermolecular force of attraction between the particles of matter. Liquids cannot be compressed much. The compressibility of liquid is almost negligible. The third state is the gaseous state. The particles are much further apart from one another as compared to solids and liquids. They have a very disorderly arrangement of particles compared to the solids and liquids. The force of attraction between the particles is negligible. Hence, particles of a gas move freely in all the directions and they show the maximum Brownian motion. Gases thus can mix or diffuse into other gases. The particles of a gas have maximum kinetic energy. They move with high speed in all directions and can exert pressure on the walls of its container. That's why we get the containers airtight. Gases neither have a definite shape nor a definite volume. They fill up the container completely, and on compressing any gas, because these are highly compressible, we can liquefy them, that is, fill in a cylinder in the form of a liquid. Gases can be compressed easily, example the LPG cylinders used at home and the CNG cylinders used in vehicles. Change of state of matter. As we have already discussed about this, that the state of matter is interchangeable. That is, interconversion is there in the states of matter. Solid can be changed into liquid, liquid to gas, gas back to liquid and liquid back to solid. The phenomena of change from one state of matter to another and then back to the original state is called interconversion of states of matter. Matter can change its state at very temperature and pressure. Water can exist in three states of matter. That is, solid as ice, liquid as water, and gas as water vapor. Now we will talk about the effect of temperature on the state of matter. On increasing the temperature of solids, the kinetic energy of the particles increases, which overcomes the forces of attraction between the particles. Thereby solid melts, that is the fusion process takes place, and is converted to a liquid. The temperature at which solid melts to become a liquid at atmospheric pressure is called its melting point. The melting point of ice is 273.16 Kelvin, or we can say 0 degrees Celsius, because 0 degrees Celsius equals to 273 Kelvin. We can take approx. The process of melting, that is change of solid state into liquid state, is also known as fusion. And then the latent heat, as I already told, that the word latent means hidden. Every object has some hidden energy in it. For example, we can take ice. If we are putting it on our palm, that area gets red because the heat energy is absorbed from the palm. Because of that, we feel somewhat irritation there, and we cannot put the ice cube for a longer time, and we remove it, and that area gets red. Or we put acetone or the nail polish remover, then we can feel somewhat cool there, because the heat energy, the energy is absorbed from the finger or the palm, and it is released into the atmosphere. Due to this, the rate of evaporation takes place. It gets faster, and we feel cool at our finger or palm. So we are going to read about latent heat. What is that? The word latent means hidden, as I told. The hidden heat which breaks the force of attraction between the molecules is known as the latent heat. Because of that only the particles gets far away. Since the heat energy is hidden in the bulk of matter, it is called the latent heat. Latent heat of fusion. The heat energy required to convert 1 kilogram of solid into liquid at atmospheric pressure at its melting point is known as the latent heat of fusion. The temperature at which a liquid starts boiling at atmospheric pressure is called its boiling point. So boiling is the bulk phenomenon. Particles from the bulk of the liquid gain energy to change into the gaseous state. For example, boiling point of water is 100 degrees Celsius, or we can say 373 Kelvin. Latent heat of vaporization. The heat energy required to convert 1 kilogram of liquid into gas at atmospheric pressure at its boiling point is known as the latent heat of vaporization. The process in which a gas on cooling turns into a liquid at a specific temperature is called condensation or liquefaction. Formation of clouds is due to the condensation of water vapor from the Earth's surface that gets evaporated or vaporized due to the sun's heat. The change of state of a substance directly from a solid to gas without changing it into the liquid state or vice versa, means from gas back to the solid, is called sublimation. The temperature at which the state of a substance changes from a liquid to a solid is called freezing point of that substance. When a solid melts, its temperature remains the same because the heat gets used up in changing the state by overcoming the forces of attraction between the particles. It is considered that it gets hidden into the contents of the beaker and is known as the latent heat. Water vapor at 373 Kelvin, that is the 100 degrees Celsius, have more energy than water at the same temperature. That's why you are going to get severe burns from the water vapor as compared to the boiling water, because the energy of the steam, the water vapor, is more as compared to the boiling water. The reason is so mentioned here because particles in steam have absorbed extra energy in the form of latent heat of vaporization. The explanation which I told you just now, you can write in a simple, easy one sentence. The particles in a steam have absorbed extra energy in the form of latent heat of vaporization. Next is what? Effect of change of pressure. Gases can be liquefied by applying pressure and reducing the temperature. When a high pressure is applied to a gas, it gets compressed, and if the temperature is lowered, the gas is liquefied. That is, the gaseous state of the matter gets changed into liquid when it is filled in the cylinder like LPG and CNG. LPG that is used in our homes, and CNG that is used in vehicles. Solid CO2, that is solid carbon dioxide, gets converted directly to gaseous state on decrease of pressure at 1 atmosphere without coming into liquid state, and this process is so called sublimation. This is the reason that solid carbon dioxide is also known as dry ice, and it is stored under high pressure. Next is what? Evaporation. Conversion of liquid state into vapor on heating is so called or termed as evaporation. The process of conversion of a substance from a liquid state to the gaseous state at any temperature below its boiling point is called evaporation or vaporization. As like we can say, when the sun rays fall on the water bodies like rivers, ponds, lakes, the water gets evaporated and goes up in the atmosphere. That helps in the formation of clouds. So, evaporation is a surface phenomena, means larger the surface, the rate of evaporation is going to be faster or increased or maximum we can say. So the factors affecting the rate of evaporation, when the evaporation is going to be higher or lower, the rate of evaporation, there is an increase or decrease, we will come to know. The rate of evaporation increases on increasing the surface area of the liquid. Means if we are going to boil water in a glass and 1 glass water in a bowl, so in which it is going to get boiled faster? It will get boiled faster in a bowl because it has a larger surface area. So means if the surface area is larger, then the rate of evaporation is also going to be faster. The rate of evaporation increases with an increase in the temperature. Decrease in the humidity, that is the amount of moisture the water vapor present, increases the rate of evaporation. If the amount of water vapor is less in the atmosphere, then the rate of evaporation is going to be higher. And if the humidity is more, means the amount of moisture is more, then the rate of evaporation will be slow. An increase in the wind speed increases the rate of evaporation. That's why we can say that the evaporation causes cooling. For example, we can take the earthen pots. So like this, you are going to prepare the notes for the chapter first, that is matter in our surroundings. Probably we have talked about all the topics, but if still there is any doubt remaining or any topic you don't understood, we can talk about that in our next video. So hope so this video was helpful to you in understanding the chapter and also in making the notes through the chapter. Thank you.